Hello, good evening, everybody, and welcome to Extra Mind. Today, the topic is prediction of iris flower classes, iris flower class prediction using k nearest neighbor. So for this, I have imported some packages like Pandas, which is a data analysis package, NumPy, which is a package for numerical Python, and a data array processing package, and matplotlib.pyplot is a 2D graph plotting library, and seaborn is also a 2D graph plotting library based on top of matplotlib. So last two libraries are actually for data visualization, and the first two libraries are for showing the data in the data frame, that is Pandas, and array processing package, that is NumPy. So here we are making the use of irish.csv, irish dataset. So this irish dataset is, well, it's downloaded from the internet, and it has got four columns like sepal length, sepal width, petal length, and petal width. These four columns are nothing but the features, and the last column, which is the variety column, is the target column. Now the sepal length, sepal width, petal width are the features column, and the last column is the variety column, which is the target column. And this target column basically consists of three classes. The first class is setosa, which is iris setosa, and the second class is versicolor, and the third class that is present within this particular column is virginica. So there are three classes which are present inside this particular data set, and this problem is nothing but it's a classification problem, it's a supervised learning problem, and a classification problem itself. Now here we have read the dataset irish.csv. Before reading the dataset, you have to upload the dataset. So you can easily upload the dataset using this browsing, and here you can wait for connect to the runtime. I have already showed you how to upload the dataset in the previous videos, so you can directly upload it from here. And after uploading the dataset, you have to read the dataset using pd.read_csv. So here the dataset is actually displayed in a data frame format, and we have done a further analysis on the data, like we have seen the information of the data using irish.info. Now this iris is nothing but it's a simple variable inside which we are reading the dataset, and irish.info is a function which basically gives you the full complete information about the data set, like it's in a data frame. Total records are 150 entries, and total there are 5 columns in the data set. And what are the columns and what are the data types that are present in the column? Float 64 means float, and this object means string values. So total 4 float values and one string value, and total 6 plus a kb memory is occupied at runtime. And irish.describe is actually the description of the data set, where only the description is shown for the numerical columns and not for any other columns. Is the column containing numerical values, where we have some attributes like count, mean, standard deviation, minimum value, maximum value from first 25%, maximum value from first 50%, and maximum value from first 75%, and the last one is maximum value from the total 100% of the data set. Next, we have irish.isNull.sum for checking is there any null values in any of the columns of the irish dataset. So we can see that everywhere it is 000. There is no such null values in the particular dataset. Now we have written here irish.shape, which presents 150 rows and 5 columns. Means total there are 150 records in the dataset and 5 columns are there. And sns.pairplot, sns.pairplot is nothing but we have actually given the pair plot of the particular dataset, where the x-axis and the y-axis actually represent the data distribution. Pair plot is generally used for data distribution. So you can see that the y axis is sepal length, sepal width, petal length, and petal width. And similarly, you can see the x axis also sepal length, sepal width, petal length, and petal width. Okay, it's both are same. And on the other hand, you can see here that from sklearn.model_selection import a train test split. From sklearn.preprocessing import standard scaler. This is actually used for scaling the data, because there is a very variance in the data set. So we need to scale the data in order to perform the or in order to make the algorithm perform better. So on the x-axis, you can see that we have taken only the features, all the features. So what are the features? The features are only sepal length, sepal width, petal length, and petal width. So we have dropped the column, the variety column. Axis one is actually for column. So we have dropped the column called variety. So now x contains all the 4 features, and y contains only the variety column, that is the target. So this is the first phase of machine learning that you have to do. You have to separate the features and the target. And the next line we have split the data set into training and the testing part. So xtrain comma xtest, ytrain comma ytest. We have used the function called train test split, which we have already imported here in the first line. And the first parameter in this train test split, the first parameter is going to be the feature, the second parameter is going to be the target, the third parameter is going to be the testing size, which is actually 20%. Okay, this is called cross validation. You can give 0.1 also, 10%, 15%, 20%, 25%, 30%, it's your choice, but not below 30%, because there are some rules for uh, cross validation, which we will do in the next class. So test underscore size equal to 0.2 means 20%. That means 80% of the data is available in the training part. And we have taken a random number, means a random division of the data. So any number you can take for random state. Here random state I have taken as 42. So random state 42 means here we are dividing the data set on a random basis. And when we are printing this y test is nothing but it contains the target of the test data, and next test contains the feature of the test data. And how much data is there in the test data? There is a 20% of the data. So total records that are present inside this particular data set, iris data set, is 150, and the test size is 0.2. So 20% of 150 is 30 records. So 30 record goes inside the testing part, and the rest 120 records goes inside the training part. So we have printed this y test to see the target. And the next is we have scaled the data. So as I said that there is a variance in the data set. So you, in order to make the model perform a better, you need to scale the data. So you need to create an object of a standard scaler. You need to create the object of a standard scaler, which is already a package present in Python. And then you need to fit transform the training data and only transform the test data. Okay, remember that you have to fit transform the train data and transform the test data. So after fit transform and transform, you can see here we have from sklearn.neighbor import kneighbor classifier. So kneighbor classifier is nothing but it is actually the algorithm package which we have imported, and here we have created the model. This is how we created the model in this particular line. And here we have taken the n neighbor as 5. As I said that n neighbors are basically odd number, so there is no tie between that, so that there is no tie, right? So n number neighbor is actually 5. You can take it as 7, you can take it as 9, 11, 13, to see which is giving you the better result. Not a very less value, like not 1 3, not like that. So because it is very sensitive to less number of k value. So after that you are going to fit the model. Fit the model means training the model. So this last line is actually where the model is getting trained within the train data, okay, using the train data. And once you get this square box, that is the k neighbor classifier, where it is written k neighbor classifier. So you can see that your model is trained. And in the next line, with the help of the predict method, we are basically testing our model. So always there is a method called predict, which is used for testing the model. So we are passing the x test, that is actually the testing feature, and we are getting a prediction. We are getting a prediction. Ypred is a variable, so we are printing the ypred, and we are getting the prediction. So you can see here the iris flower is actually giving you the prediction over here. So versicolor, setosa, virginica, we are getting the 30 outputs. Why 30 outputs? Because 30 data was present in our testing set. So we will get a 30 output, means 30 prediction. And once you find out the accuracy of the model, so for that also there is a package called from sklearn.matrix import accuracy underscore score. So accuracy underscore score, we have created a function, and the first parameter is the test data, and the second parameter is the predicted data, which we have already predicted previously cell in the previous cell. And when we have printed the accuracy, you can see that since this is a very small data, we are getting accuracy of 100%. So not an issue. When we have tested this model, we can see that I have tested this using the data which is already present inside our actual data. So from this actual presence, I have taken the 4 records. Any of the records you can take, but it will always be in the form of an array. So you can see there inside 2 square brackets I have taken. So 4 values I have taken, and then you have to transform the value, since it is a test data, which I have already told you earlier. You have to transform the test data. Okay, you have to transform the test record. So here also we have transformed the test record. We have transformed the test record, and after transforming the test record, you have to pass the test record inside the predict function using the knn. Knn means it is actually our model. It is actually our model. And when you just print the prediction, you can see you are getting the output, that is virginica. You are getting the output, that is virginica. So you can change this. You can change this, basically these values, and you can see that you are getting your desired outputs, and you can take the data from this data set itself. You can also provide your own values to give to get the desired result of your choice. So this is the prediction of iris flower using the k nearest neighbor. And that's all. Thank you, everybody.